Namaskar friends, welcome to Electronics Technology YouTube channel. Topic of electronics technology news is modular 3D printed microrobots. Tiny, adaptable robots now walk, swim, and collaborate across varied terrains, thanks to a modular 3D printed design, paving the way for versatile microrobotics in medicine, environmental monitoring, and beyond. Head modules for real-time interaction. A new generation of 3D printed microrobots is breaking ground in adaptability and functionality, promising to reshape how robotics can operate across diverse real-world environments. Developed by researchers at Seoul National University, these modular microrobots, each smaller than a centimeter, can walk on various surfaces, swim, and even collaborate in groups, offering a major leap toward general-purpose microscale robotics. Unlike traditional microrobots, which are often purpose-built for narrow applications such as drug delivery or disease diagnostics, these new systems employ a modular architecture. This design allows researchers and engineers to swap components for different tasks, echoing the flexibility seen in drone technology. Each robot consists of a central body connected to interchangeable modules, legs for movement across flat, rough, or aquatic terrains, heads for real-time interaction, and connectors that allow multiple units to operate as one coordinated swarm. Fully 3D printed modular microrobots capable of performing a broad range of tasks across diverse environments are demonstrated. The authors propose modular design as an approach for the development of general-purpose microrobots. The key advancement lies in fabrication. The team used a custom multi-material 3D printer capable of producing up to 8 identical microrobot units per run, dramatically improving scalability and precision. This process not only speeds up production, but also enables on-demand customization. Modules can be printed, reconfigured for specific missions, from environmental monitoring to targeted biomedical operations. In testing, the microrobots demonstrated robust locomotion across sand, water, and solid ground, maintaining stability and coordination even in challenging conditions. The researchers credit their modular design for this versatility, allowing the robots to mimic natural adaptability seen in insects while remaining highly controllable. The implications stretch far beyond the lab. Modular microrobotics could eventually enable swarms of micromachines to navigate confined or hazardous spaces, assist in minimally invasive surgery, or perform distributed sensing in environmental research. The 3D printing process also paves the way for affordable large-scale production, an essential step toward commercialization. By merging modular architecture with advanced 3D printing materials, Seoul National University's research signals a future where microrobots are not just tiny specialists, but dynamic general-purpose systems ready to operate in almost any environment. Do you like this video? Please subscribe, share, like, and press bell icon for getting notifications of Electronics Technology YouTube channel. And for searching my YouTube channel, please write at the rate Electronics Technology 50.